As you can see from my title, it's a rather ambitious journey that I would like to take you on for the next 45, 50 minutes or so. So let me start with some motivation for choosing it. And my first motivation, I hope you can see it all in the back, otherwise there is still room here at the front, is intellectual. If I'm honest to myself, I invite you to think about it, I believe we do not really have a shared story to tell about the coherence of the whole field of linguistics and about the way each linguistic subdiscipline contributes to that shared story, not to our students or colleagues in other fields, and that hinders progress and interdisciplinary collaboration. Such a shared story is, moreover, socially important, I believe. Many of us share the experience that there are many misconceptions about language in society that can cause sometimes serious harm in the relations between people and between communities. But without a shared story about the field, we are never going to persuade the world that basic knowledge about language should be an integral component of general education, just as much as physics, chemistry, the basic principles of those are, and so on. So it's these motivations that make it worthwhile for me to invite you to think about the question, what in general, so rather abstractly, but this may fit the school of philosophy where we are today, counts as an explanation in our field. So I want to start with the question how complex phenomena in general are explained. Basically, this involves establishing a relation between the complex phenomenon at hand and the properties of more elementary, more simple phenomena that the complex thing consists of and their interaction. So, for example, we may say that we explain the properties of solids and fluid substances in terms of the properties of molecules and their interaction under certain conditions, temperature, and so on. That is, we reduce the properties of the complex phenomenon to the interaction between simpler ones. Still, the properties of the complex phenomenon are novel in the sense that they are not to be found at the level of the simpler ones as such. No single molecule is fluid, for example. A good explanation by reduction also allows us to show how the higher level phenomena emerge as characteristic features of the complex phenomenon, and moreover, how these properties may in turn influence the behavior of the more elementary ones. So reduction and emergence are two directions in which we can and should travel the single staircase of scientific explanation. Some other instances are listed here. Take money, for example. It is the development of trade, elementary, that gives rise to the emergence of money, and the role and emergence of money can be explained in terms of the elementary properties of trade. But once money is on the stage, it changes the way the economy works in fundamental ways. So we can and should look at explanations in the language sciences in a similar way, attempt to reduce its properties to more elementary features of cognition and communication, showing how it can have emerged from these and also how it subsequently influences them. Besides such a commitment to explanation, empirical scientists also have a commitment to evidence, to facts as we can observe them. So lexical sociologist Dirk Gerards, already mentioned by Magda, once unequivocally and sort of bluntly maybe for some, stated this as follows: the primary fact of linguistics is the behavior of language users. The label cognitive sciences that we often use these days for our fields may not immediately suggest this, but I think in a sense it is a truism. Since cognition itself is not directly observable. Even expressing a linguistic intuition is a type of behavior. But more importantly for my purposes today, this allows us to make a direct link to the explanatory staircase. human communication, communicative behavior, is a more elementary phenomenon than language. Many more species than us have it, and it may be expected to enter into explanations of language phenomena. Moreover, human communication also has to be recognized as a special case of communicative behavior of organisms, and thus the study of language ultimately also has to be seen as a special case of the study of animal communication, which is a major component of the field of behavioral biology, formerly known as ethology and before that as animal psychology. The commitments to scientific explanation and to evidence thus straightforwardly imply a biological commitment, as I call it here, for us as linguists, in my view, in the sense that our explanatory projects should satisfy general criteria for explanations in behavioral biology. Now, fortunately for us, it so happens that there is general consensus in that field, despite many theoretical controversies and methodological controversies that also exist there, about the proper model for explanations. And this consensus can be traced back to an article by Nico Tinbergen, published in 1963, so 60 years ago now. Because of its importance to the field of ethology, its 50th anniversary was widely celebrated 10 years ago. Tinbergen's article was a response to rather heated debates and controversies in the field of behavioral biology of that time, which included fights even over the proper way of doing science. And the interesting historical thing about it is that Tinbergen's paper was a great help in overcoming these controversies. The first rhetorical step that he took was to formulate the question, the aim of ethology, of behavioral biology, in such a way that nobody could disagree. What behavioral biologists try to do is to answer the question why an animal is doing the things it does, it behaves in the way it does. Taking an example from Tinbergen's own work, why is this young seagull picking at the red spot on another bird's beak, in fact, at any red spot? But the most important contribution that he made was what he had to say about the nature of the proper answer. That is an explanation of the behavior, an answer to the why question. The point is that the biological explanation of such a feature, a behavioral feature, can, as a matter of principle, never exist of a single causal story. It has to be a composite one, comprising 4 different types of because clauses, so to speak. Hence the label Tinbergen's 4 whys in the field of, for this model of explanation in the field of behavioral biology. So the first one, the first type of answers concerns the mechanism. The animal is doing this because it perceived something, this was processed by its cognitive system in some way, and then something was processed as a result in its motor cortex, sending a signal to certain muscles, and so on. That is the mechanistic. The second is about ontogeny. A fertilized egg doesn't have any, display any behavior. So another question, answer to the why question, is that the animal has developed in such a way that it displays this behavior and may lose it again in a subsequent stage, for example. The third specifies the function of the behavior. In biological terms, the animal is doing this because it contributes something, so what exactly it is has to be specified, to its survival and its chances to reproduce. In the seagull case, getting food from a parent. And the fourth, finally, is the evolutionary story, phylogeny. The animal is doing this because it is descendant from a lineage of ancestors that has evolved the disposition or possibility to behave this way. In biological publications, the first 2 kinds of stories are commonly grouped together as proximate causes and the latter as ultimate. What this reflects is a fundamental distinction between causality at the level of individual organisms and at the population level. not only phylogeny, but also function, has the effects of a trait's contribution to fitness, has effects on the next generation. That's how it's defined. The distinction between these two dimensions of biological explanations is a consequence of the radical conceptual shift that was implicated in the discovery of evolutionary theory by Darwin. What Darwin discovered was not just natural selection, but especially a new kind of gradual change that nobody had thought of before. First of all, we have variation in a population of replicating entities, such as organisms, and secondly, selection in the sense that the variant F has some feature that has some higher chance of being replicated than others. It is, and we have then third, at least some degree of heritability of those features. Then Darwin realized it is inevitable that in the relative frequency of F in the population over generations will increase. Thus, evolution came to be understood as the change in relative frequencies of variance in a population over generation, an algorithmic process that can and will work when these three conditions are met without any intentional agent planning it, as with natural selection. Now, the fact that evolution is not pre-programmed is the background of a catchphrase frequently encountered in textbooks, namely that only populations evolve, the only role of individuals in the evolutionary process is to be selected. No individual dinosaur ever became a bit more bird-like in its lifetime. This makes evolution a process of gradual change that is fundamentally different from that of the development of an individual organism, which is guided, at least to a considerable extent, by properties of the fertilized egg that starts it out, and where we speak of growth and life history, concepts that have no application in phylogenetic explanations. So as a consequence of the discovery of the theory of evolution, a fundamental split has occurred between the conventional meanings, as I indicate here, of the word evolution on the one hand and the word development on the other hand. Now, in biology, population thinking permeates the whole field. It is the concept of evolution in this sense that provides the conceptual framework creating coherence in the field with all its specializations, as expressed in this famous Dozansky quote. And as we have seen, the Tinbergian model of explanation also incorporates population thinking as a crucial element. Each of the four explanatory quadrants that we have here exhibits this reduction and emergence character of scientific explanations, and so does the framework as a whole, allowing for that, with the quadrants focusing on elementary processes that interact with each other on different timescales. So, given a biological commitment of language, which I argued for, what do we get when we try to apply this model of explanation to language? Now, for several aspects, this seems pretty straightforward. We can formulate the basic question that all linguists are interested in answering as, why do speakers say the things they do in exactly the way they say it? So, as a special case of the general explanatory question of behavioral biology. And when we turn to proximate individual level why question, the mechanism quadrant can be implemented by involving the relation between a communicative situation, some observable behavior, the way this is processed in the brain, etc. And in the case of ontogeny, of course, we are especially dealing with the object of language acquisition research. But a complication arises when we turn to the question of ultimate population level explanations, because we are dealing with learned behavior that is transmitted culturally, not genetically. Human languages are not the only vocal communication systems that are transmitted through imitative learning. I listed some other species that exhibit this here. Cultural transmission of behavioral patterns leads to cultural rather than genetic evolution. Another instance of Darwin's algorithm along with genetic evolution. For example, we find dialects of chaffing songs, repertoires in Europe that can all be characterized as cases of descent with modification, to use Darwin's terms, with considerable behavioral differences between groups of the same species, that is biologically still the same species. So in cases like these, including human languages, we are dealing with not just one, but two interlocking population level processes. From these two, it is no doubt cultural evolution that primarily explains the properties of languages as we encounter them and birdsong repertoires, if only because it operates at a shorter timescale than genetic evolution. So we have to take into account, in thinking about a Tinbergian model of explanation for linguistics, that actual languages are not just a product of interactions between individuals and their physical environment over many generations, but also of cultural evolution, glossogeny, as Jespersen and Fitch called it. In our Tinbergian model, this implies that the functional explanation of a linguistic feature will have to deal with its contribution to communicative success, determining its chances of being used again, and the evolutionary one with the history of the language. And I will get back to both of these a little bit later. But several features of languages, given these two population level processes, may in fact be expected to have resulted from the co-evolution of genes and culture. Once something a bit language-like is on the scene, the availability of this new tool for communication changes the fitness landscape, so to speak. One important candidate for such a process is the fact that language use is energetically cheap, while it is at the same time reliable and relatively stable. It supports efficient and effective communication within a cultural group, also with non-kin, genetically unrelated individuals, as Herford, Fitch, and others have repeatedly noted. This combination of features is somewhat unexpected from a purely individual, focused Darwinian perspective and in need of a special explanation. But in linguistics, we have the tools for it. We have the building blocks for that. As we all know from our basic introduction to pragmatics, the primary explanatory principle of human communication is that of cooperation, analyzed by Grice. The way people normally interpret the communicative behavior of other people only makes sense when we assume that they implicitly expect each other's contributions to be cooperative. In a strictly individualistic Darwinian perspective, this is a risky attitude, so it will not easily evolve. But within human groups, members share a basic trust in each other, and if they don't, the group dissolves. It is this context that allows language use to be cheap and reliable at the same time, as Herford in this work, in this quote, and others has noted. The competition is in general a barrier to cooperativeness, and competition is Darwinian, from a Darwinian perspective, basic. So it has actually only evolved a few times in the long history of life on Earth. But when it did, it had spectacular consequences for the further history of life, because the cooperative collectives became a completely new kind of individual entities interacting with the environment and undergoing selection. This is why the famous book that describes and analyzes these events has major transitions in its title. In the human case, it is especially the reliance on the increased reliance on learned behavior in culture that allowed our ancestors to overcome the barrier to cooperativeness. Individuals cannot change their genetic makeup, but they can relatively easily, more easily, change their behavior if that is learned. that makes it easier to start exploiting the benefits of cooperation under certain conditions, such as hunting large prey and distributing labor in complex projects. In turn, this has led to large differences between human groups that are not based on genetics. Now, once such a way of life is present, it constitutes a niche for further genetic adaptation, especially for social cognitive infrastructure, as Tomasello has called it, that is a psychological tendency to want to be like others in the group and to rapidly and reliably find out and learn systematic of behavior in one's group. Especially for children, their survival depends on it. It thereby also produces the conditions for the emergence of conventionality. And conventionality is a basic characteristic of languages. The emergence of conventionality has been analyzed in depth by David Lewis in 1969 in this monograph. In his analysis, a convention is a special kind of behavioral regularity in a community that provides members with tools for solving a coordination problem, and human communication is such a type of problem. A simple example of a coordination problem is traveling on the same road, two people traveling on the same road in opposite direction, so each has to choose which side to take to avoid collision and continue the journey. It is a coordination problem because the optimal choice for one depends on the optimal choice for the other and the other way around, vice versa. So in the absence of a salient solution, there is a chance of a deadlock. But once a choice has successfully been made, the specific solution adopted thereby becomes more salient and increases the chances of being adopted again. In addition, when one observes others in a community solving such a problem in a particular way, that will also increase its salience and chances of being adopted. And ultimately, the ever-increasing frequency of a particular strategy makes it become the expected one. And that is when we have achieved the status of a convention, an expected regularity. People fearlessly drive towards each other at dangerously high speeds. In other words, in general word terms, a convention is a mutually expected solution to a recurrent coordination problem in a community that facilitates cooperation in solving problems and effectively enhances it, the capacity to solve it. It is inherent to coordination problems that there are several solutions that are basically equivalent. If one specific kind of solution would intrinsically be optimal, that would be the one that people adopt. And we do not call it then a convention, but just the best solution. This is the source of arbitrariness of a convention. We conform to a convention just because everybody else in the community conforms to it. We expect everybody to conform, and we know we are ourselves expected to conform. But we are prepared to behave differently when we find ourselves in a different community with a different convention. Driving on the right side or the left side of the road works equally well as a way of solving the problem of passing one another quickly. The choice is entirely dependent on the community that we happen to find ourselves in. Linguistic signs exhibit just these properties. Using zee for the concept sea and meer for the concept lake works just as well as the other way around, as long as everybody in the community does it in the same way. The meaning of the forms is entirely dependent on the question whether we find ourselves in the community of speakers of Dutch or of German. What Lewis' analysis also makes clear is that conventions are a population level phenomenon, as Keller, who wrote this well-known book, and partly based on Lewis, also emphasizes. The study of the emergence and change of linguistic conventions as pursued in historical linguistics thus fills the cultural evolutionary quadrant in our Tinbergian model of explanation. In this perspective, we can characterize a language as a repertoire, a population in the technical sense, of conventional devices for mental coordination in a particular community. Not only comprising words, but also morphemes and constructions or rules of grammar, whatever your preferred terminology. It implies a fundamental distinction between linguistic conventions as a social, cultural phenomenon and knowledge of language in individuals, while recognizing that these two levels are still causally connected. Individual speakers replicate the conventional items with varying frequency, thus driving cultural evolution. This idea of a difference and a connection between the two is beautifully implemented, in my view, in this recent monograph by Schmidt, in which he uses this visual metaphor of one engine driving two feedback loops. At the community level, it is the recurrent usage that produces conventions, which in turn socially license the use of linguistic items. At the individual level, it is repeated experience that produces cognitive routines, allowing a speaker to produce and understand linguistic utterances. Okay, so with this story so far, relating various existing insights from biology, philosophy, psychology, and linguistics, I claim that we can take major steps towards a Tinbergian model for explanation for our discipline. Linguistic conventions emerge in the process of cooperative communication, which has itself evolved in the context of increasing cooperativeness and its cognitive infrastructure in the history of our species. The model incorporates the crucial conceptual distinction between population and individual level processes of causes and effects. And what I want to do in the remainder of my talk is to discuss some consequences, some of which may come perhaps still as a surprise, and explore some further perspectives. So the general Tinbergian model can be schematically depicted in this way, as I did before. In the mechanism quadrant, the linguistic instantiation includes the study of processing as practiced in psycho and neurolinguistics, also pragmatics, at least as the study of communicative interaction in real time, online. The ontogeny quadrant is mainly to be equated with the study of language acquisition, but also processes, the study of language attrition finds its place there. In the ultimate population level dimension, we are dealing, first of all, with the conventional function of linguistic signs, which contribute to a language user's communicative success, and also with features of group identity and other aspects studied in sociolinguistics relating to an individual's social success. The fourth quadrant, finally, is concerned with the cultural evolution of language items, language change as studied in historical linguistics, and the emergence of new languages. In addition, of course, the biological commitment implies also that we account for the second population level process of genetic evolution, specifically with the function of language for enhancing cooperation and thus reproductive success of human beings and the emergence of the human cultural niche in our evolutionary past. Adopting this line of thinking may seem natural by now, I hope so at least, to some extent to you, but it has some surprising consequences in other respects. You may have noted, for example, that the study of grammar is absent from this overview of subdisciplines that I just presented. The reason is that the study of the way linguistic items can and cannot be combined in utterances refers to two very different things when we systematically distinguish between the population and individual level processes. At the population level, grammar denotes the regularities of behavior in a community, the set of conventions that define ways for proper conventional patterns of combination. It may be equated with Chomsky's notion of e-language, external to an individual, although Chomsky meant it a bit differently. It is this kind of information that one usually finds in so-called descriptive grammars, books with titles of the type A Grammar of X. At the individual level, the word grammar denotes the cognitive resources, including routines, memorized chunks, and so on, by which a particular language user performs the task of producing and understanding utterances in a way that the chances of communicative success are optimized. Her I language. I for internal. These resources may in fact include routines and habits that do not necessarily correspond to the community level conventions. In fact, variation in these systems between individuals is completely tolerable as long as the actual communicative behavior of speakers with different internal grammars converges on the patterns defined by the community's conventions to a sufficient degree. Recent work has been now systematically shown that there is actually a considerable amount of individual variation in grammatical knowledge. Now, on the one hand, this may seem to complicate the life of grammarians, but I actually think that embracing this distinction offers only advantages, including for our general goal of overcoming unnecessary divisions between approaches in linguistics. I'm now thinking in particular of the distinctions between levels of explanation that are probably better known among and established among cognitive scientists than Tinbergen's, namely those introduced by David Marr in 1982. Marr proposes a general model for the explanation of information processing systems. So that only concerns the mechanism quadrant in our Tinbergian model. In the first philosophical chapter of his book, Marr gives the simple example of doing addition, mapping sets of numbers onto other numbers as a specific way to illustrate the basic point, before discussing his actual topic, namely vision, the second one mentioned here, which crucially involves the mapping of two-dimensional arrays of pixels to a three-dimensional knowledge of what is in the environment. Language is also mentioned in this chapter as involving a mapping from message to some observable product, and I will get back to that. But the point here is that Marr's general point, and those are its levels, is that a proper explanation within this information processing approach of any individual system must consist of a connected story at three levels, as he calls it. The first concerns an explicit characterization of the nature of the task. What is it that this information processing system is doing? The second concerns the question how the system is doing it, representations and algorithm. And the final level, it is shown how this algorithm is physically implemented in hardware, so to speak. But take the simple example of addition. The theory answering the question, what is the task, is the theoretical mathematical definition of addition, comprising the successor function and some axioms, such as that the result of adding 0 is the same as x, and so on. But at the how level, choices have to be made. Representations have to be chosen. Are we representing numbers binary or in a decimal system or some way else? And we have to choose an algorithm. In what steps are the elements of the representation manipulated? And finally, it has to be shown how the representations and the algorithm are implemented in semiconductors or neurons, for example. The elementary point is that even this simple example illustrates, is that there are constraints between these levels, but the specification as one never determines the other. There are always choices to be made. In particular, the theory at the what level does not determine a specific representation, and it is not itself an algorithm. It is not a mental, let alone a physical implementation. Still, it is needed as part of a whole explanation, because it tells us as scientists why an algorithm contains certain steps and not others, for example. In the case of vision, it's much more complicated. That's Meyer's actual case, but it has the same logic. At the what level, we have to specify what the mapping between two-dimensional image and a three-dimensional model consists of. At the how level, we have to make choices about the manner of representation and algorithms for design in the case of robotic optics vision, and investigate it empirically in the case of organisms. And finally, it must be shown how this is all implemented. And in the case of the scientific study of vision in organisms, the exact nature of vision at the what level is itself an empirical matter. Vision is itself an evolved feature. For example, at the early stages in the evolution of the vertebrate eye, no full model of a 3D environment could be produced. So in terms of the Tinbergian model, we can say that the specification of the present function of the visual system, which is itself a product of evolution, provides the content of the abstract mapping function in the mechanism theory. Having a three-dimensional model of the environment, after all, contributes to the fitness of an organism, and that is what the cognitive mechanism, the information processing system, produces. This link holds for all evolved cognitive functions, unlike the universal abstract mathematical definition of addition. Now, when we turn to language, the same logic applies again. At the what level, the specification of the mapping between an observable signal and a change in mental state will have to comprise at least an abstract theory of cooperative communication and an equally abstract characterization of links between form and meaning in the language evolved, that is, a grammar in some sense. At the how level, choices have to be made, as in the other cases, about the kinds of representations and the algorithms being used. At the physical level, well, we used to have only neurons to think of, but since the rise of large language models, we may perhaps also consider these at least partially an implementation of some features of language. Now, I take the idea of an abstract theory of cooperative communication as a characterization of the task model rather than a processing model from this paper by Thurs and Rubio-Renondez, which I found in general quite useful for clarifying Meyer's distinctions. But I want to focus now on the grammar component. Meyer makes some interesting comments, brief but interesting, in this philosophical chapter, referring to Chomsky's aspect. He calls it a true computational theory in his sense, that is, a theory at the what level, not at the algorithmic level. The specification of which is, in his words, a completely different endeavor. He relates his distinction to Chomsky's distinction between competence and performance, although, as he notes, Chomsky's characterization is a bit different. But we can indeed find statements in Chomsky's work that support Meyer's interpretation. In particular, Chomsky's equation of grammar with a device relating semantic to phonetic representations in combination with the statement that such a device is not itself a theory of the way language users construct such mappings. It is only a theory at the what level. In view of what I have said so far, it should be clear that I think that making a distinction in this way makes sense and is very useful. But what I do want to propose, analogously to what I said previously about the what level of vision, is that when we embed Meyer's distinctions in the Tinbergian model, we can actually take the description of a community-level grammar as the specification of at least part of the task model in an explanatory account of language processing. The task model is thus not itself represented in the mind of speakers, which seems to me in the spirit of Meyer's characterization of the difference between these two levels and which I find useful. The descriptive grammar is thus not something separate from the theory of linguistic cognition. It is a crucial component linking the population level function to the individual level mechanisms. In short, I conclude first that Meyer's model of explanation of information processing can be completely incorporated into the Tinbergian biological one for behavior that I discussed, in fact, in a way that provides additional insights. And secondly, I want to argue that all theories of mental grammars have to account for both what and how at both levels. There is ample room for debate and discussion and controversy on both of these levels, given the complexity of the language phenomenon, no surprise. But it should not be obfuscated by a confusion of the levels. So by way of overall conclusion, I would like to point out, indeed, it's been implicit in the past, that the Tinbergian model is the all-inclusive one, providing a comprehensive conceptual framework for linguistic subdisciplines. And in fact, I would say for the study of human culture and cognition more generally, because it incorporates this distinction between population and individual level explanations in a fundamental way. And scientists, linguists included, can only achieve results and make progress if they can build on each other's results. And to that end, they have to be able to make sense of their fellow scientists' stories. I claim that that's what I want to claim, that a story of the type that I tried to develop here can be of great help in that respect. No subdiscipline in our domain can claim to be the theory of language, while each has an indispensable contribution to make to the overall explanatory enterprise that we share, and that is aimed at answering the question, why the things that speakers say exhibit the characteristics that they do. Thank you for your attention.
Thank you so much, Arie, for this wonderful talk. Thanks so much.